we've been given the three sides, 23, 32, 49. So I've kind of drawn them, this is relatively accurate here. So 23 is the short side that goes with angle A. 32 is the middle side that goes with angle B, and 49 is the long side that goes with angle C. So we need to find the angle. So this is a side, side, side situation. And a side, side, side means we need to use cosine law. Another way we can think of this is, I have no angle opposite side pairing. I can't use sine law. So I'm going to be forced to use cosine law here. So I'm going to solve for C, the angle C. So I'm going to go C squared is equal to A squared plus B squared minus 2 times A times B cosine of angle C. And again, what's important is that we need to relate that side with that angle. Okay? So as long as that's done, we can then do this correctly. So we're going to end up with 49 squared minus 23 squared minus 32 squared. Okay, so I get rid of the pluses with minus. I get rid of the times here with divide. So divide by 2, divide by 23, divide by 32. That's equal to cosine of angle C. So solving for the cosine of angle C, okay, we need to calculate that value. So we end up with 49 squared minus 23 squared minus 32 squared, okay, divided by I end up with negative 0.576. Okay, so it looks like this angle is obtuse. Okay, so that's going to be, since the cosine is negative, I'm going to undo that cosine, and I end up with 125. So angle C is equal to 125.18 degrees when I round it. Okay, so I've solved for one angle. Now, since that angle is obtuse, I'm going to be fairly confident using sine law, which is kind of the easier laws, because I don't have to worry about the theta 2 or getting an ambiguous case, although we'll use angle side side. We won't need to worry about ambiguous case because that angle is so big that whatever angle we solve for, in this case is going to be angle A, that cannot be the supplementary angle. Okay, so it's always going to be the theta 1 angle. So here I'm going to solve for angle A. So I'm going to use sine law. So sine A over 23 is equal to the known, although it wasn't known at the beginning, now it's a known angle and opposite side pairing. So solving for sine A. So sine A in this case, let's see here, we get 23 times the sine of 128.518, and then divided by 49 gives us sine A equals 0.3836, so 384 I'm going to round it to, and I'm going to undo that sign, and I end up with angle A is equal to 22.56 degrees. Okay, so there's my angle A, 22.56 degrees. I should just clarify that. 22.56 degrees. And then using deduction, we can subtract from 180 to find the other one. Okay, so the third angle is going to be 32.26 degrees. Okay, so there's using the cosine law and the sine law to be able to solve for the three angles of that triangle. All right, so here the Space Needle is in Seattle, and the person, observer at the top of this 30-meter building looks up at an angle of 79 degrees to the top of the Space Needle and looks down at an angle of 45 degrees to see the base. And we want to find the height of this Space Needle to the nearest, determine the height of the Space Needle. So we know that this length here is 30 from here to here. We know this angle here. We don't know any of these other measurements. So we could use this, break this down, and we could find out this length here. Well, actually, we do know this length here. It's going to be, since it's 45 degrees, it's 45 degrees. This is also going to be 30 degrees here. What we can do is we could find out this length and use cosine law to find out that side length. However, since we already know the partial length, and it is easier to use right triangle trig, we'll just solve this for x in this right triangle trig problem. So we know that x divided by 30 is going to equal the tan of 79 degrees. Tan 79 degrees. Solving for x, we end up with 30 times tan 79. Okay, so we do tan 79 times 30. And that gives us that portion is going to have a height of 154.3, we'll round that to 34 meters. Okay, so that's 154.34 meters. So the total height is going to end up being 184.34 meters. Okay, so that's going to be the height of the Space Needle. Now again, we could have done this slightly differently and use the cosine law. However, if we can use right triangle trig, it's probably going to be easier to use right triangle trig to solve a problem like this.